Stack. If we look at this data structure conceptually, a stack is like a data structure that is having one open end, the other end is closed. It's like a utensil, like a glass. Whatever the item that you add to it is called push. What it is called? Push. It is called push. So whatever the item that you will push first will go to the bottom of the stack. If you enter other items, they will be pushed on top of it, and then on top of it, then on top of it. This way, you will only be able to take out the item which was entered the last. So that is why sometimes we refer to this stack as last in, first out data structure. So they might refer to this as LIFO, LIFO, or the stack. Again, this is the code which is actually describing this conceptually. Again, via an array. So let's say this is an array. I have written so many codes for it, simplified and with linked list and without linked list. These all are updated. Okay? These all are updated. So array, we know that it is a dynamic data structure. There are two types of data structure. Dynamic, which on the go can increase or decrease its size. If it requires more data, it captures from the open memory, uses it. If it does not require, it wants to delete it, not just delete the node, it releases it so that other programs could use it. That is dynamic. Linked list is dynamic. And array is static. Once it is made, its size is fixed. If its size is fixed, it means if we require more values, we cannot. But somehow, I don't know, we are utilizing arrays, and the concept of utilizing array is a linked list, which is being utilized as another data structure. That is 3-tier or 3-layer programming, I say. So now, without any complexity, we are just looking at an array, which is a stack, that's it. So let's call it stack array. If I like to push, I will create a constant top of stack. Mind it in your book and past paper question, top of stack is the whole one word, T-O-P-O bada of, then S capital stack, and then P bada pointer, top of stack pointer. All right. So we have that pointer, and that would be all of the pointers, no matter what, are always global variables, and the constants as well. So input a value. If pointer is equal to top of the pointer, then output error. Which error is this? We don't have space and we are trying to fill in overflow. The specific error is called overflow. And when we don't have a value and we try to delete, underflow. So if pointer is equal to top of stack, then output error, else pointer is equal to pointer plus 1. The concept is that pointer is there. You have new value to enter. You first move the pointer and enter the value at the pointer location. Then you have a new value, you improve the pointer, and then you add the value to that pointer. Okay? So at the start, your pointer is 0, null. Plus 1 goes there at the value, plus 1 goes there at the value, plus 1 goes there at the value, plus 1, it is now 5 at the value, and then it will check it before adding 1 to it. And the other operation is called pop. If pointer is equal to 0, then output error. Obviously, 0 means nothing is there. Which error is this? Underflow. Else x is equal to data. You have to take that data assigned to a variable so that we could keep it to use it later. And then pointer is equal to pointer minus 1. You read the value, decrease the pointer. That's it. I have written a program, simple array, all the operations, everything is there. Let me show you that program, and then we go with the past paper question fast. Stack simple implementation. It's not opening from here, I open it here. पाथ इतना बड़ा हो गया, पहले भी एरर आया मेरे पास. पाथ इतना बड़ा है कि सिस्टम फाइल नहीं ओपन कर पा रहा. See, I made a menu here. Stack pointer. This is the pointer. Top of stack pointer नहीं, stack pointer. और stack में हमारे पास 9 values हैं. ये pop है. If it is less than 1, underflow. Otherwise, decrease it. And console dot write line the item that is popped, and push. Same. All right, exactly same code. So let's see how it is working. Push to stack, enter value A. Push to stack, enter value Z. Push to stack, enter value D. So what's in the stack now? A, then Z, then D. A is at the bottom, then Z, and then D. So pop. What will be popped first? D. D is popped. You can see. Then Z, and then A. So system is working. Okay? It is not robust programming because if you enter something else, system will crash. Anyways, runtime errors. Any question about it? So this is simple. Now, there is a stack implementation here. From the book, corrected as a linked list. Okay? Now look at the question. This is summer 15. Stack or queue के जो questions आए थे. Okay, let's solve those questions. Sorry. May June 2015, paper 4-2, question 6, I believe. Yes. This is Q. No, we need stack 4-3. Yes, 4-3. Summer 15, 4-3, question 5. Remember those shapes? जो हमने भी बाइनरी ट्री में देखे थे. A stack abstract data type. अच्छा, now it at page 628 of your book. At page 628 of your book, अगर आप linked list पढ़ेंगे, तो linked list says that you can only add data at the start of the linked list. ठीक है? Oh, sorry, free list. And when you fetch data, you will fetch the data from the start of your free list. What does that mean? Means that free list is a list. When you want to have more data, as we discussed that this linked list is a dynamic data structure, means whenever we require more data to add to our list, we will be taking the data from the free list. So if we are taking the data from the free list, we will always be taking the data from the head of the free list, means from the start. And when we are deleting the data, a node from the list, our list, we will be deleting but adding that deleted node to the start of the free list. Whereas linked list has to be a sorted list. So if it is a sorted list, it means when adding the data, we can add the data at the start, we can append the data at the end, we can add the data in between, means insert. We have to keep the order. So if we have to keep the order, we have to add the data at any location which is required. We have to keep the sequence. But when this theory comes to stack, none of us is reading this for the very first time, right? So page 28 of your book says that these are the special cases for your linked list. If it is a stack, we are always adding data at the end of the list. End of the list is where the null pointer is. Means we are always appending. We are not maintaining what? The order. And when we are popping, we are also popping from the end of the list where the null pointer is. So that last in first out. Similarly, if you are using your linked list as a queue, you are adding, queue is what? First in, first out. You are adding at the tail of the linked list and you are reading from the head of the linked list. Head is where the root pointer is. Head pointer is. Are we good? 628. Oh, 328. 328. Excited हो गया. 300 pages बढ़ा दिए. 328. Sorry. All right. Anyways, so let's start this. A stack abstract data type ADT has these associated operations: create a stack, add item to stack, and remove item from the stack. आप लोगों की खुशकिस्मती ये है कि अब सारे क्वेश्चंस आ गए हैं सिवाय हैश टेबल के. Let's they start implementing hash table as a linked list. I have no idea. Only that is remaining, otherwise all of it is covered. Create a stack, add item to stack, push, and remove item from stack, pop. So this is happening. So create a stack. See, a stack grows from the bottom. ऐसे ही था ना? When we have this conceptual form of a stack, it's a glass. Whatever you put, it goes to the bottom of the glass, then on top of it, then on top of it, then on top of it. A time comes that glass is full. So we will treat this as a glass. So push Ali. And remember, this is a linked list. And what I said, we will always be adding at the tail of linked list. So Ali, acha, we need to have stack pointer as well. So push Ali, then push Jack, and then pop Jack. Pop, pop. Then push Ben. Then push Ben. Then push Ahmad. And then pop Ahmad. And then push what? Jatinder. Alright? And then top of stack is this. Remember to use full names. Look in the book, use same names. Top of stack. And then this one is pointing down. Okay? This is null. Is it understood? So it is actually like this. And your top of stack is here. Jatinder, Ben, and Ali. It's like that. Understood? Are you good? Remember, again, pointers in the stack are not just ordinary pointer, they are part of the linked list. They are part of the I understand what's happening. These are part of the linked list. So whenever this is initialized, they all will be pointing to each other, and the last one will be pointing to null. ठीक है बेटे? So यहाँ पे हम जीरो से नल बनाएंगे क्योंकि फर्स्ट वैल्यू जो है हमारी वो है. सही है? चल रहा है. So top of stack would be 0, free pointer would be 1. These all will be initialized to null. You know what null in string? Double quotation without anything in between. And these would be pointing to, this would be pointing to 2, 3, 4, 5, 6, 7, 8, 9, 10 and null. This is how it is initialized. Create stack thing. So remember, when they're using a procedure with create, they are most probably initializing the linked list. Push. Stack new name. Free pointer, top of stack pointer. Remember, use these names. Do not use other names. And temporary pointer. So they are pushing. So let's solve this. Pop. Report error if stack is empty. So what you have to check? Pop means there are no items. Top of stack pointer क्या हुआ है? 0. और हम जो है वो रिट्रीव करने की, पॉप करने की कोशिश कर रहे हैं. So if top of stack pointer is equal to 0, then output error underflow, else output stack top of stack pointer dot name, ऊपर जो भी होगा टॉप ऑफ स्टैक पे वो आउटपुट हो जाएगा. Take a copy of the current top of stack pointer. Temporary pointer we have to use here. Temporary pointer is equal to top of stack pointer. Top of stack pointer वो कैसे करते हैं? अच्छा, इसके बाद आ रहा है अपडेट द टॉप ऑफ स्टैक पॉइंटर. टॉप ऑफ स्टैक पॉइंटर इज इक्वल टू स्टैक टेम्पररी पॉइंटर डॉट पॉइंटर. हम आगे बढ़े, ठीक है. टॉप ऑफ स्टैक पॉइंटर हमें नीचे आना है ना, इज इक्वल टू स्टैक एरेज टेम्पररी पॉइंटर. आप यहां पे टॉप ऑफ स्टैक पॉइंटर भी लिख सकते हैं क्योंकि हमने टेम्पररी पॉइंटर में डाटा लिया है तो हम टेम्पररी पॉइंटर लिख रहे हैं. डॉट पॉइंटर means it will go down one position. Acha, and then link release node to the free list. Whatever the new thing came up. Acha, it's not just that I am writing this in favor of the book. I have written my own notes own programs as well, which I have made from a different point of view. Go through those programs if you find time as well. Now, whatever is in temporary pointer will be now become the part of free pointer. ठीक है? So stack temporary pointer stack temporary pointer dot pointer is equal to free pointer. Next column. And free pointer is equal to the temporary one. And this is and if. The best thing to understand this code is to actually conceptually draw the diagram and move your pointers and everything together. You read and act on it. And then you will realize कि हाँ सही चल रहा है. Last वाली अपडेट वाली लाइन में हमने ये किया है कि टॉप ऑफ स्टैक पॉइंटर को क्योंकि हमने पॉप किया है ना, तो मैं बताता हूं. देखो इसमें क्या हो रहा था, जब हम इसको पॉप कर रहे थे तो इसको हम नीचे लेके जा रहे थे ना, तो इसको हमने इसके बराबर कर दिया है. जहां पर हम खड़े हुए उसके पॉइंटर के बराबर कर दिया, तो टॉप ऑफ स्टैक नीचे चला जाएगा बिकॉज इट इज पॉइंटिंग डाउन. ऑलराइट, so if you remove this, top of stack will reach there and this will be finished because these are part of the free list. Okay.